On explorations this time, building a new home beneath the sea, on a moon 400 million miles from Earth. This is Explorations, the story of man's greatest journey. Our Earth is unique. Of all the planets in our solar system, it is the only one capable of supporting complex life. "30 million forms of plants and animals and 10 million different species thrive here. They do so because our planet has a breathable, oxygen-rich atmosphere, a plentiful supply of water and heat and light. All of which comes from the only star in our solar system, the Sun. Life on Earth depends on the Sun. Man has always known this, and so worshipped the Sun as his god. Britain's ancient Stonehenge was erected to greet the midsummer sun. In Egypt, the passage of the sun was embodied in the god Amun-Ra. We still worship the sun. We're still awestruck by its majesty and power. We're transfixed by an eclipse. We marvel at the kaleidoscopic effects of the northern lights. The sun gives life. But of all bodies in our solar system, the sun is also the most dangerous. Its radiation is deadly. On Earth, we're protected by our atmosphere. But when we go beyond that atmosphere, when we go towards the sun, we're playing with fire. In 1973, Skylab, a manned space station, was on a mission to observe the sun. During takeoff, Skylab's heat shield was damaged. The space station lost power, and the temperature inside began to rise.
What happened is 60 seconds into the flight, that heat shield popped open, and of course it's still in the air stream, and so the airstream tore the heat shield off, and when it did that, it unlocked both solar wings.
For 10 days, Skylab's crew had to operate on less than half power. The temperature had risen steadily, reaching a deadly 126 degrees Fahrenheit.
Right away on day one, we went in and got this temporary heat shield rigged, which we were able to rig from inside. We were able to put it out through one of the airlocks, and we were able to push just like an umbrella pole and mylar sheets that then popped open like an umbrella, and then we were able to pull it back in to where it was just offset by a few inches off the side.
Amazingly, it worked. Skylab began to cool down. Its mission to extend our knowledge of the sun could continue. For the next 9 months, Skylab took 180,000 images of the sun. We saw solar flares, planet-sized eruptions of boiling gas, and huge magnetic forces in action around the sun's surface. We gazed at the violent heart of the star, which gives life to our home. We wanted to know more. We sent more missions. The SOHO probe of NASA and the European Space Agency revealed huge seismic quakes on the surface of the Sun. Japan's probe Yoko, launched in 1991, sent back stunning X-ray images of the Sun's swirling corona. And now, we may be on the verge of discovering the Sun's greatest secret. The Genesis probe is going on a 20-million-mile, 3-year-long journey. Its mission, to collect particles of solar wind, literally pieces of the Sun, produced by gases streaming from its corona. At the end of its mission, the number of solar wind particles collected by Genesis will be the equivalent of a few grains of salt. From these, scientists hope to determine how our Sun and our universe were created. These few grains might reveal the very origins of life itself. The Sun, which gives us life, will also eventually take it away. The Sun is expanding. In about 5 billion years, as the Sun gets hotter, the Earth will begin to burn. Water will evaporate, and life will cease. This is a long way off. But there are other dangers, like black holes. Black holes are formed when stars explode, an event called a supernova. Some stars are so huge, 100 times bigger than our own Sun, that when they explode, they collapse in on themselves until they are microscopic in size, but incredibly dense and powerful. This is gravity gone mad.
Even though black holes are dark and invisible, it doesn't mean they have no effects. They're extremely strong vortices, and they pull matter in these swirling winds around them, a lot like a tornado.
There is yet another danger, which is uncomfortably close. Asteroids. Asteroids are lumps of rock floating in space. They can be as small as 6 feet or as large as 600 miles in length. Some asteroids are so big, they have their own moons. If asteroids hit another object, the crash is cataclysmic. Most of the craters on the Moon are the result of asteroid impact. And this is what asteroids have done when they've collided with Earth. The asteroid that made this crater in Arizona 49,000 years ago was 40 meters in diameter and traveling at 25 miles per second. Scientists have calculated that an asteroid some 200 times bigger than the Arizona asteroid traveling at half the speed will be enough to rip a hole the size of the Netherlands in the world's surface. To protect ourselves, we have to know where asteroids are. We can do this with high-definition telescopes.
They do impact the Earth routinely, but mostly we're talking objects that are very small. What we're concerned about are those objects that actually penetrate the Earth's atmosphere in a large form. And with that in mind, on average, we're discovering about 4 a month.
We've devised deterrents, like hitting an approaching asteroid with nuclear bombs. Or pushing it away with chemical rockets. But scientists are under no illusions. An asteroid will hit Earth at some time in the future. With so many dangers, sooner or later, life on Earth will expire. But there is hope, and it lies in outer space. Now, space is no longer a place to explore just out of curiosity or the pursuit of knowledge. Exploring our universe has become an urgent necessity for the future survival of our species.
We tend to think of the Earth as forever, the eternal sea, we call it. But yet, when we start looking at the planets in the solar system, we realize that they're not eternal, that the Earth is in some sense halfway through its lifetime, its expected lifetime.
Our Earth is dying. We need to find other homes in space. The strongest candidate for that new home is Mars, our next-door neighbor. Since 1976, we have been exploring Mars in detail. Our knowledge of Mars leapt forward with the Viking Mars mission. And then, in the late 1990s, the Mars Global Surveyor showed us these gullies and debris flow features. These suggest there might be frozen water at the planet's poles. Water is the basis and starting point for all successful life forms.
If we assume that there is water tied up in the polar caps, and as the sun gets much brighter than it is now and the surface temperature of Mars gets above the melting point, then the polar caps are just going to turn into oceans, and Mars will once again have a water-rich environment, and that could trigger a release of large amounts of CO2 very quickly.
But why wait for the sun to do this in 7 billion years' time? In a process that scientists call terraforming, we can raise the temperature artificially and do it soon.
There's many ways to warm Mars, but probably the one that's the most well-defined and the most practical is to introduce into the Martian atmosphere small quantities of super greenhouse gases, like chlorofluorocarbons.
Scientists estimate that terraforming could make Mars habitable within the next few centuries. The possibility of a Martian home for man is becoming a reality. But even if we could live on Mars, we must first get there. The 100 million mile journey would take 3 years. 3 years traveling in space. It would be the most demanding voyage ever undertaken by human beings. We would have to stay clean and fit in zero gravity. Our spaceship would have to be self-sustaining, breeding or growing its own stocks of food. Getting to Mars will be a physical battle for survival, but the greatest challenge will be the psychological effects of being in space for so long and so far from Earth.
It's like a voluntary death in a way in which you say goodbye to family and friends and humanity. You say goodbye to the entire thing, even though you are picking up a life, a new life out there.
Any new home we form on Mars would not last. It would only be temporary. If the Earth fell victim to the expanding sun, eventually so too will Mars. Another home will have to be found, and scientists think they found a perfect site, far from the expanding, devouring sun. It isn't a planet, it's a moon. Smaller than the Earth's moon, with a surface of hard ice, it orbits the giant planet Jupiter. It's called Europa. As the sun gets hotter, Europa's icy surface will melt, creating the water essential to our survival. Beneath the surface of this now liquid planet, it may be possible to construct human habitations, domes beneath the seas of Europa. Will this be our home in centuries to come? We're already rehearsing for this incredible possibility. In 1991, 8 people entered a biosphere in America's Arizona desert. This 3-acre glass structure was a self-sustaining environment with enough plants, water, and animals to allow humans to exist as if in a new extraterrestrial home. The experiment lasted 2 years.
Can you take these ecological systems that have evolved on a planetary scale? Essentially, the answer was yes. We can take these animals and systems, stick them in an incredibly small container, and it still works.
By the time our sun engulfs Earth, we might already be safe beneath the seas of an alien moon.
Good work, guys.
In exploring space, man has overcome remarkable, unexpected, and complex challenges.
This transmission is coming to you approximately halfway between the moon and the Earth.
Through triumphs and disasters, we've come to understand more about ourselves and our place in the universe. Driving all our endeavors, from the very beginning, is the desire to answer one persistent question. Are we alone?
I know when I'm out in space that there is life out there. I know that from a logical, common sense point of view, but I also tend to feel it intuitively. The acceptance of other living beings out there, that's the beginning of a joint effort. That's the beginning of communication.
We're already making efforts to contact other intelligent life forms. We've stretched out the hand of friendship. We've told them who we are, where we are, how to get to us. Most scientists believe that when we do make contact with extraterrestrials, it will be through radio signals. SETI is the search for extraterrestrial intelligence. This project uses powerful radio telescopes to listen for signs of alien life. We're tuning in. If they're transmitting, we're listening.
It really just comes down to this. You know, there's so much cosmic real estate, such an incredible number of stars, yet it's hard to believe that this is the only bit of real estate in the entire cosmos that happens to be populated by beings that are capable of developing, for example, radio technology.
It's possible that intelligent beings have already answered our call. Their answer might take many light years to get to us. Would we understand it if we saw it? In 1977, SETI astronomers picked up a radio signal from a distant star. They'd never seen one like it before. The scientist who first heard the signal just wrote "wow" by its side. The wow signal has yet to be explained. There are over 100,000 million stars in our galaxy alone. Up to 100 billion galaxies in the universe. But rather than deterring scientists, the sheer number of stars and galaxies is a source of inspiration.
There is no doubt that there is a multitude of civilizations in our galaxy to be found. I made an equation known as the Drake equation, which predicts this. If you use the equation to estimate the number of detectable civilizations, you end up with a result that there are about 10,000 detectable civilizations in the galaxy.
Our ambassadors in space, Pioneer and the Voyager probes, will carry on traveling for the next 2 million years. The Earth and man might be long extinct by then. If someone picks up our cosmic postcard, they'll know one thing for certain: that we were a species driven by the need to explore.